Okay, so in today's class, we'll discuss about Docker and we'll see how Docker, what is Docker and what is the usage of Docker, right? What benefit we'll get using Docker and to make containerizations and all. So we are going to learn a new technique or new form like new platform and new tools Docker to create the containerizations. So like virtualizations, right? We have heard about the virtualizations, VM, virtual machines. Similarly, we are going to work on the containerization. So let's understand what is containerizations and what is the usage of that. Okay, so before moving to that Docker, I hope you guys would have done some practice on the Jenkins and all, right? So once we finish the Docker, we'll integrate Docker with Jenkins and see how we can trigger the Docker directly from the Jenkins. Okay, so let's start. First of all, let's understand what is Docker. Okay, let me make it slide slow. So what is the Docker? It's a simple word. Docker is a platform used to containerize your software. Used to containerize your software using which you can easily build your application, package them with the dependencies required for your application into the container. And further, these containers are easily shipped to run on other machines. So Docker is a platform used to containerize your software using which you can easily build your applications. Like, so containerize your software means whatever the softwares. So whenever you are building an applications, right? Whenever you are designing any applications or writing any product, so what happens? You need some sort of softwares, right? Some binaries, some libraries, and with the combinations of those, you need to put together and make the applications to run, right? Either whenever you are going to run the applications, if you are going to run in the virtual machine, suppose you have a Java applications you have built, and that Java applications you need to deploy into one of the virtual machine. I'm not talking about now containerizations. I'm talking about the one virtual machine. So in that virtual machine, suppose the Java applications, whatever things is required for that applications to run, the first thing is Java to be installed first on the VM, and then that particular libraries or the binaries should be deployed, and some sort of configuration should be there, and then you have to deploy the applications to run, right? So same thing in containerizations. What we are going to do, we are going to pack together everything in one place and make the container to run, make the applications to run in the containerizations. We'll just discuss the benefit of using containerizations than virtualization. Okay, we'll see in next slide. So Docker is simplifying the DevOps methodology by allowing developers to create templates called image. So create templates called image using which you can create these lightweight virtual machines called as containers. So the Docker is simplifying the DevOps methodology. Actually, whatever the tools we are going to learn, in DevOps, Docker and Kubernetes, actually simplifying the meaning of DevOps. Okay, we'll just learn how it helps us. Okay, because if you see, we had different kind of methodologies, right? Before we have waterfall methodology, then we got agile methodology, right? In agile methodology, what happens? We used to get some, right? We used to get some piece of code, right? We have to make separate iterations, modules, and then we work on that, right? And then deliver. Similarly, in this DevOps methodology, DevOps, there is no methodology. It's not actually a methodology. It follows agile methodology, right? DevOps follows agile methodology, right? So in that, what happens? It actually simplifying the DevOps methodology. Docker is simplifying. Now, when we are going to use the container, we need to use one template. That template is called the image. Okay, we'll see how we can create our own image and default built-in image, and we can use the user defined image, like how we can create our own image also. So Docker is making these things easier for software industry, giving them the capability to automate the infrastructure isolate the applications, maintaining consistency and improving the resource utilization. So Docker is making things easier for software industries, giving them the capability to automate the infrastructure, isolate the applications. So the isolating the applications is the most important things which we are going to achieve using Docker. And maintaining the consistency and improving the resource utilization. These three things we are going to see, and that is what the benefit will get in containerizations compared to virtualizations. Okay, let's see. So we understand what is Docker. It is a platform to use to containerize your software, containerize your application. Then what is virtualizations? Virtualization refers to importing a guest operating system on your host operating system, allowing developers to run multiple operating systems on different VMs, while all of them run on the same host, thereby eliminating the need to provide extra hardware resources. So if you have a laptop, right? You have the laptop, you have the hardware machines, right? And you have the required software like resources. So when we talk about the hardware resources will be your hard drive, your keyboard, your laptop, right? Screen and everything is the hardware. The softwares and whatever the softwares and the hardware resources like the memory, the storage, and all these details, right? So memory, the card memory, whatever we have, suppose we have 8 GB of laptop, we have 1 terabyte of storage, right? Those 1 terabyte of storage and those 8 GB of RAM, 8 GB of memory, those will be used by the in virtualization. What happened? Your laptop, and you want to create, suppose 4 virtual machines, right? So what you have to do in the 4 virtual machines, whatever you create, and you have to share few resources to them, right? Suppose 4 virtual machines, 8 GB of RAM, the total laptop is having 8 GB of RAM, and you are going to share 2 GB to one virtual machine, 2 GB to another, 2 GB to another, and 4 equal if shared, right? So in that case, what happened in tomorrow, suppose you need another virtual machines to be created, then you will not have sufficient memory to be there to allocate, right? Okay, we'll discuss the problem and all and then next slides. So while these virtual machines were introduced, they helped the industry in many ways, enabling multiple operating systems on the same machine. You know, on the same machines, as I told, we can have, suppose in this laptop, suppose I want to create 4 virtual machines. I can create 4 virtual machines, and each virtual machines have different operating systems. One I can keep as Ubuntu, one I can keep CentOS, and one I can keep Windows, right? Those I can create virtual machines, different virtual machines I can create. So it was cheaper than the previous methods due to less compact infrastructure setup. Obviously, it will be cheaper, right? In 4 virtual machines we can create, and we can just deploy 4 applications into that. Instead of purchasing 4 laptops, we can create 4 virtual machines. In one laptop, we'll have the 4 virtual machines. 4 virtual machines will have the 4 applications, right? So obviously, it will be cheaper. If there is any failure state, it was easy to recover and do its maintenance. Faster provisioning of applications and resources required for the task. Faster provisioning, because it will be a few commands you have to just execute to create and set up the machines and do the rest of the things. And deploy, it will be easy. An increase in IT productivity, efficiency, and responsiveness. So what? The virtualizations. In case of virtualizations, these are the things, benefits we used to get it. But in containerizations, what is happening? What is the containerization? Containerizations is a technique where the virtualizations is being brought containerizations to an operating system level. So here what was happening? It was happening. Virtual refers to importing guest operating system on your host operating system, allowing developers to run multiple operating systems. That's one. And it actually provides hardware resources, eliminating to the hardware resources. But in this case, what is happening? The containerizations is a technique where the virtualization is being brought containerizations. Whatever the virtualizations we used, that we used to create containerizations on an operating system level. On an operating system level, right? We'll see how in the operating system level it helps us. In containerizations, we virtualize the operating system resources. It is more efficient as there is no guest operating system consuming the host resources. So in case of virtualizations, we had the guest operating system, but here we'll not have the guest operating system. Whatever the host operating systems we have, the containerizations will work on your laptop directly. As many as container you can create. No need of any virtual machines. Okay. So as containers utilize only the host operating system and share relevant libraries and resources only when it is required. So the required binaries and libraries of containers run on the host kernel, leading to the faster processing and the execution. So containerization or containers is a lightweight virtualization technology acting as an alternative to hypervisor virtualizations. So what is this hypervisor virtualizations? So actually hypervisor is a technique or is a like the VMware, the company name, right? The VMware who created the virtual machines. So they had the software or the program or machines which called hypervisor. Using this hypervisor, actually we can achieve the virtualizations. Okay. So bundle any application in a container and run them without thinking of any dependencies, libraries, and binaries. So whenever we talk about the container, we'll never worry about any dependencies, because before creating the container itself, whatever dependencies required for an applications to run, everything will be bundled together in the image, and that image we are going to use to create the container. So we are not going to miss any libraries or binaries in production. So in case of virtualizations, what was happening, whenever you go for a production deployment, you might forget to deploy the required libraries, binaries, right? The same thing when you would have done testing in the test platform, right? Your application should be running fine. But when you go to the production environment, you might forget, suppose due to some human error, you forget to copy one library binary. What will happen? The applications will fail to respond. Then what will happen? Then production issues will come, right? But in case of containerizations, what happened? Whatever the things we have already bundled and tested in the test platform, the same thing, after the testing is done, you just put into the production environment. And that will run because the container will have already the required libraries and binaries which already been tested in the test environment. Right? That image can be transferred to the, that's why in the very beginning, if the, here it says, build, share, and run anywhere. Build, share, and run anywhere. That means in Docker, in case of Docker, we can build our applications, our product, right? In any platform, and share it to anywhere, and then we can run it without worrying about the dependencies, right? So think about a real-time scenario, right? Whenever you are like, you would have seen the containers, right? In the sea, you would have the containers, right? There would be multiple containers. A ship would be containing multiple containers, right? So in one of the containers, they would have, suppose if we are exporting something or importing something from outside, what do we need? Maybe we are suppose importing some kind of medicines, right? Or some kind of glass items or Chinese product or something we are interested in. So what they will do, they will not keep everything in one container, right? They cannot keep medicines, glass items, or iron items, or something, wood items combined together, and they cannot put in a container, because if they put in one container, what will happen? When they reach to India or to the shore, everything would have broken or damaged, right? So to isolate those products, we can create separate containers. For glass items, one container with sealed pack with required supports there, not to break. And for medicines, we'll have separate container. For wood item, for iron items, we'll have separate containers. Now what happens? We isolated everything, right? And those things can be easily saved from a far distance to the from source to destinations without any worrying about damages. So that is here in the software line. In the DevOps, container is going to help exactly the same way. Okay, let's see. The next, what is the advantages of this? Containers are small and lighter in weight because they share the same OS kernel. Why they use the same OS kernel? Because they are using the same hardware of the host operating system, because they are using the host operating systems. They're not using the guest operating system. We'll talk about what is guest and what is host, don't worry, in the next slide. So it does not take much time to boot off. In a fractions of seconds, it will deploy everything and make your applications ready to use within fractions of seconds. High performance with lower resource utilizations. That is the advantages of Docker. Sorry, not Docker, containers. So with the help of Docker, we are going to work with containers. Okay. So in case of containerization, all the containers are sharing a similar host operating system. Multiple containers get created for every type of applications, making them faster, that too without wasting resources, unlike virtualizations where kernel for every OS was required. So which utilizes a lot of resources from the host operating system, which utilizes a lot of resources from the host operating system. Okay, so these are the advantages. We'll see in details, complete hands-on. That time you'll understand more. Now I'm just telling you some theoretical to understand what is the Docker, what is the containers, what benefits we are going to get it. Then we are going to now directly work on the lab, right? See, here is the diagram. If you see this particular VM part, the virtual machines part, you'll understand here clearly. The virtual machine, we have the host operating system. We have the host operating system, right? And this host operating system, we have the using the hypervisor, we created, suppose 3 virtual machines. We created, suppose 3. What happened? So here, in this, suppose we have 3 virtual machines. And these 3 virtual machines, we have the host operating system. Suppose in my case, suppose in my laptop, right? My laptop has, suppose, Mac operating system. On that, I have created 3 virtual machines. And in these 3 virtual machines, I have to install different operating systems. 3 operating systems I need to be installed in this virtual machine. Suppose I have this VM1, VM2, and VM3. In these 3, we are going to install 3 different operating systems. And we have to pay for this, right? Operating system, whenever we are going to operating in the organizations, right? You are going to use the enterprise versions of the operating system, and you have to pay for that. For each machine, if you're going to install, you have to pay for that. And then each machine, you have to install the required binaries and libraries, then you have to deploy your applications. Similarly, things in 3 virtual machines you have to do, right? So what happens here, it is heavy weighted because of this guest operating systems. We have the host operating system on top of our guest operating systems, and then we have all these things. So it is costly and time effective and takes more time to work. But in case of containers, if you understand here, we have a host operating system, and then we have to install the Docker engine. We have to install the container engine or Docker engine there. Docker you have to install, that's all. So once you create the Docker, you don't have necessarily required the guest operating system. Here, we don't need in containers in Docker, in our Docker case or container case, we don't need guest operating systems to be there. So we can simply create the containers with the required libraries and binaries and bundle together with the applications deployed and run it. So when we run it, what will happen? It will use the resources of the host operating system. It will use the resources of the host operating system. So the kernel of the host operating system, the required resources like the memory, the storage, everything will be used in the host operating system. But here, in this case, these virtual machines, these applications, and all these things, they will use the kernel of this caged operating system. Okay, and we have to assign some resources to these particular machines in order to run. But here, these resources, everything will be there with host operating systems, and they use as per their requirements.
So Ranjit, like on the performance level, like whether the containers or the individual VMs will have more performance, or how it will be, Ranjit?
Performance wise, containers will be has more performance because of its lightweight in nature. Why lightweight? Because it does not have the extra operating systems there, right? It does not require the extra kernel. It works on the same operating system, same kernel here, right? The performance wise, it will be faster. Containers are the faster, but it is virtual machines are a little lower.
Okay. Okay.
Let's see, and you'll understand more. Virtualization and container, what is the difference? Virtualizes the hardware resources in case of virtualization, but in case of containerization, it virtualizes only the operating system resources, and it requires the complete operating system installations for every VM. It requires complete operating system, but in case of containerization, it installs container only over a host operating system, as we saw in this diagram, right? Now, a kernel is installed again for every virtualized OS. So obviously, for every time you install the operating systems, you need a kernel to be there, right? Each operating system has a kernel. Now, only the underlying host operating system's kernel is used. This is heavyweight virtualized, and this is lightweight. Limited performance, native performance, fully isolated, process level isolated. We are getting isolations in both cases. In case of virtualizations, we get isolations. Also, in case of containerizations, we get isolations. But here is fully isolated because we have 3 virtual machines and all these things. So we are getting these things. And then in case of this process level isolated, we'll see how it is working. Right. Let's see. Okay. So here, if you see the comparison between the resources, how the resources are being used, by different in case of virtual machines and in case of Docker. So what happened here, if you see the total, okay, just a second, guys. I'll be back 1 second, 2 minutes. Okay, so if you see here, the comparison of the resource utilizations, I was talking about how it is helping in case of resource utilizations, right? So if you see this particular diagram here, in case of virtualization machines, we have suppose total memory of 16 GB, and we have created 3 virtual machines as per our previous diagram. And when we create virtual machines, that time itself we have to allocate memory. Suppose we have 16 GB of RAM, right? 16 GB of memory. And in case of 16 GB memory, I created 3 virtual machines. Suppose assign 6 GB, 4 GB, 6 GB each. That means we don't have anything left in the host. Everything is assigned to this particular virtual machines. And if I need to create another virtual machines, I will not have any memory left to assign, to allocate. So what will happen? We have to either increase the memory, the host operating system memory, or we don't need anything to be there, or we have to get another machines to create. But here, if you see here, in case of virtualizations, what happens? We have allocated 6 GB to VM1 and 4 GB is used, 2 GB is free. That means this 2 GB is wasted, right? No one else will use this one. Similarly, here 1 GB wasted, and here suppose 4 GB wasted. You can see here memory used total 9 GB and memory wasted total 7 GB. So 7 GB of memory is blocked and cannot be allotted or allocated to a new virtual machines. As we already have assigned these things, we cannot assign any left over here in the virtual machine level to another virtual machines, right? So here what will happen? It's a total failure of assigning or allotting the resources here. If you need to do that one, then you have to reallocate memory again to lower it and then assign to another machines. It will take time and it's actually cost effective. In case of Docker, what happens? Same case, suppose 16 GB and allotted memory is 4 GB. Allotted memory is suppose 30 GB. Okay, it is wrongly written. 35 GB. Suppose some 6 GB or 6 GB. So what will happen? Anything, if you allotted 10 GB also fine, 35 GB also fine, but what will it will use? It will use as for its requirement. Now suppose this particular app, particular container is using 4 GB and this particular container 3 GB and 2 GB. So total 9 GB is used and the 7 GB will be free. So we can create another container and that container can use. Let's give you a real-time example here. If you have a water barrel at your home, right? If you have a water barrel at your home and you have few people there sitting there, and what if either you can get one 1 liter bottle, get some water, 1 liter water, and hand over to one person to drink. So what will happen? Whatever water he will drink, whatever he feels thirsty, right? And the rest will be left over in the bottle, right? And another case, what you can do, you get one glass, get some water from the barrel and give to that another person. So what will happen? He'll drink whatever also thirsty, but he'll drink all the glasses, right? There you know, the resources is used whatever is required, right? Here in this case, what happened? Only a glass of water he drank, but the rest of the water is still there in the barrel. But in case of bottle, what happened? We got the 1 liter, but he drank only 200 or 300 ml, but still 700 ml still there in the bottle. And suppose he just used directly tossed in mouth and nobody can else drink that bottle, right? So he has to only use it. So that is the case in case of virtualizations machines and Docker, right? So here that is the virtualizations and
Ranjit, like here also we have allocated, right? So if you see like app 1, 2, and 3, so you have allocated memory, right? For the first one, you allocated 4 GB.
Yeah.
Something you have allocated, right?
So here also we allocated, but the thing is here whatever memory you even allocated, the memory whatever it use, that will be used and the rest of the things will be free. Why? Because why it is used, how much that the amount it is required and the rest it left over. Why? We already have discussed few slides before, right? Why?
Because we already do the dependencies libraries and so
no, because the containers, because the Docker the containerizations, in case of containerization, what happens? It uses the host operating system. It uses the host operating system's resources. That means In host operating systems, you have suppose 16 GB memory, and it uses only 4 GB memory, and the rest of the things will be there in the host operating systems. But here, in case of virtualizations, we are alerting directly to the different machines. If anything left, and that will be part of this VM1 and not to the host operating system. It will be under the guest operating system. But here, as we are using the base host operating system, so my laptop being used, suppose, and my laptop will have the same memory. Whatever the memory is being used by the container applications one, the rest of the things will be free. Okay.
Okay, Ranjit.
Okay. Now, Docker architecture. So now you understood the basics of containerizations and virtualizations, why we need containerization. Why I'm explaining more, because that is, if you don't understand why you're going for containerizations, if you ask some questions, then you may not answer it, right? What is the benefit of using the containerizations? These are the benefits of things, whatever I just discussed, right? Next, let's understand about the Docker architecture. Docker uses a client-server architecture. Okay, Docker uses a client-server architecture. It will be very easy, very simplified, very simple to learn. Okay, so the Docker client consists of Docker build, pull, and run. Build, pull, and run. The client talks to the Docker daemon, which further helps in building, running, and distributing the Docker containers. So Docker uses a client-server architecture. It has only client and server, client and daemon, CLI, command line interface, and the daemon. So you have to just put the command and you'll get a response back from the server. That's all. The Docker client consists of Docker build, pull, and run. These are the commands we are going to execute from the client side. So the client talks to the Docker daemon, which is nothing but the server side, which further helps in building, running, and distributing the Docker containers. Docker client and daemon can be operated on the same system. Otherwise, you can connect to the Docker client to the remote Docker daemon. These both communicates with each other using the REST API or Unix socket. So we can install both Docker client and server in the same same machine, or else you can separate them also. You can keep client in one place, you can keep server in one place, and you can connect to that through API, right? So the basic architecture is client, host, and registry. Docker consists of 3 parts, okay? Client, host is the server, and Docker registry, which is dockerhub.com. So registry is nothing but the storage area or the source code management kind of things. It's like where you can register or store your images, That is the Docker Hub registry, okay? We'll see everything we'll learn in Docker, don't worry, okay? Docker registry. Now, this is the diagram, okay? This is the client, see, client, host, and registry. So in case of client, we are just using some few commands. Client is nothing but your CLI. What is the CLI? The command line interface or any GUI or any API you are going to, client side, you are going to execute the commands. So the Docker build, when you use the Docker build, it will just build the image and create that image and pull that image or run any container, okay? So in the client side, when we execute these things, it will talk with the Docker daemon, which is on the server side, right? Then Docker daemon will build. If we are going to build, then Docker daemon will build an image. If you're going to run, then Docker daemon will create a container, right? Once a container and images, once the images is created, you can store this image in the registry. We can store the image in the registry, and then we can pull the image from registry and create the container. This is very beautiful things, guys, and very easy to understand. When we do the real time, right? Just understand this image. Keep in mind, we'll just in the client side, we'll just execute it. Docker daemon will handle those requests, create images, and that images can be kept it in the registry. Also, if you want the Docker daemon to pull something from the registry, you can do that. Pull, it will go here, pull that image, come to the server, and there you create the container. It's very simple. Okay, let's understand further. What is Docker client? It is a primary way for many Docker users to interact with Docker. That is what I was telling, the CLI thing, right? Command line interface through which you will interact with the server, right? So you just command line utility or other tools which uses the Docker API in order to communicate with the Docker team. That is the client. The Docker client can communicate with more than one daemon. If you have the setups, if you have more than one daemons, like if you have more than one Docker servers there, then you can select to communicate with more daemon. In Docker host, we have Docker daemon, containers, and images. So let's understand the object on the Docker host, then we'll proceed towards the function of the Docker daemon. Okay, what is the Docker daemon? If you see here, in Docker host, we have Docker daemon, containers, and images. Docker daemon, right? Docker daemon helps in listening requests for Docker API. Docker daemon helps in listening requests for Docker API, and it helps in managing the Docker objects. It helps managing the Docker objects such as images, containers, and volumes. There are lots of objects we'll talk when we work on that. Then daemon is used to build an image based on the user's input, then save in the registry. So what daemon does, as we have seen, it does build, pull, and run. Build means when we build, it will create the image, that object, and it can store in the registry. When you could pull, then that image can be pulled, then can create run, then it will create the container. In case you don't want to create an image, then simply pull an image from the Docker Hub. It's the registry, okay, where you store all your images. It's a repository kind of thing, okay, storage where you store your. So if you don't want to build in any image, you can simply pull that image and create the container. Then in case you want to create the running instance of your Docker image, issue a run command which will create a Docker container. Also, Docker daemon can communicate with other daemons to manage the Docker services. What is the Docker registry? Simply, as I told, Docker registry is a repository for Docker images, which is used for creating the Docker containers, which is used to creating the Docker containers. So one can use local or private registry or use the Docker Hub, which is the most popular social example of Docker repository. So this Docker Hub is a Docker's native repositories where you'll find all kind of images, built-in images, and your images. You can create private and public or local repositories where you can store your images. I'll show you that everything in class, okay? So what is the Docker objects we're talking about? We have mostly two objects there. And many objects are there. Mostly talk about these two objects, image and container. What is image? A Docker image is a type of recipe or template. 1 second, guys. Okay, so we have these two Docker objects. One is the image. So what is the image? As I said, a Docker image is a type of recipe or a template which can be used for creating the Docker containers, which can be used for creating the Docker containers, including the steps for creating the necessary software. Okay, so the Docker image, as I said, is a template which can be used to creating the Docker containers, including the steps creating necessary software. So in that image, actually a bundle of the things, whatever we need it. It's actually a template which contains the all instructions which a container need to run, which an applications need to run in a container. So what is the container? Container is a type of virtual machine which is created from the instructions found within the Docker image. So a type of virtual machine which is created from the instructions found within the Docker image. So a running instance of a Docker image which consists of an entire package required to run an application. So that is the container. Okay, let's see more further about this. Okay, so we'll talk about the installations now. So that's all about the theoretical and fundamentals on the Docker. There's not much. Now let's go on and do some theoretical, some installations of the Docker. So how will do it? It will be very simple, guys. Okay, it will be very simple ways to do that. So let me just connect to the AWS side, and I'll just get to one server there, and there we'll just try to install software. Okay, I'll try to install the operating system. Sorry, Docker. Right. Let me go ahead and quickly use this one. Okay, just give me a second. I'm just going to try quickly uh, turn on one EC2 instances, and there I'll show you how to install this Docker and the required softwares, right? Let's quickly do that. Okay, so the instances I just started. Just hold on for a few seconds, let it run, then we'll start doing that. You can do practice also, guys. Okay, we can do practice. Okay, so by the time it gets running, okay, we have this server gets up. What we'll do, I'll show you that registry part. Okay, so what is that? The registry, Docker registry you can use to store your images. Okay, store your images and you can get also inbuilt images which you can use in your project, right? Let me just go through that one. So the URL for this is hub.docker.com. Okay, hub.docker.com. This is the registry. This is the web official registry of Docker. This is the official registry of Docker. So what I can say here, you can register yourself. It is free. Okay, it is free to use. You can click on the register and start working on that. You don't have to pay anything for that, and you can freely use it. Okay, now what I'm going to, let me sign in for that, for my talk things. I don't forget my. Okay, guys, I'm stopping my screen sharing for a few seconds. Okay, so I just got it. It is suppose Docker Ranjit, continue, and the password. The password. Okay, so I have registered myself, and when I just log in, I can see Docker for Ranjit, which is my registry ID. Okay, I have registered myself, and you can see I have a few images which I have created and put it here. Okay, there are a few images which people have also downloaded. 33 times this one has downloaded, and this has 49 times this particular image has been downloaded by the people. Okay, now when you either you sign in or not, also what you can do, let me just log out first here, sign out. Even though you don't have sign out or have not registered also, you can simply search any images. Suppose I want, suppose the operating system, Ubuntu operating system's image. Okay, so what I can do, I can just simply search for here, Ubuntu. See, we have these Ubuntu images available. Remember, guys, this registry will have, this is a repository system where it contains all the image storage and details. Okay, now this Ubuntu image, we have this Ubuntu image, and you can see here we have this tag called Docker official image. This Docker official image, whenever you are actually using in your company, right, you make sure that you always use Docker official images, not the image which is created by someone else. Okay, if you see here, we have all are the Docker official image, and it is verified publisher. Someone has verified it. It's verified publisher, and it's just check. This is 1 billion plus downloaded. Ubuntu has been downloaded 1 billion plus times. Okay, if I just click on this particular one, and it gives us the command how to pull this particular Ubuntu image. Simple, very simple. Okay, and also it has all the tags and all. If I go all the details, what is Ubuntu, about this image, little image, you can get it all these details here. Okay, and also if you just go to different versions or tags, click on these tags, and you'll find the entire history of the tags, which tag you want to use. Right, it has a different versions of the tag, 22.4, lunar, this number, kinetic, all these are the, it has multiple things, right? 50 or 100 pages of the tags are there. So whatever tag you need, you have to just copy. See here, Docker pull Ubuntu latest. This is the latest tag. If you want to use rolling tag, you can use Docker pull Ubuntu :rolling. I'll just explain and do in hands-on completely. Don't worry about that. Okay. And if you want to find anything else, any image, suppose if you want to find HTTPD, like the Apache web server, right? Select here. See, HTTPD official image. If you want to search for MySQL database, if you are going to use, search for MySQL, and you'll find MySQL official image. When we do the demo and the project, I'll show you all the images usage of all these images. Okay, don't worry about that. Anything, if you want to search it here, if you want to search here Jenkins, even you can find Jenkins image also here. You can find Jenkins image here. See, Jenkins image, official image Jenkins. Now, this is the things, right? And if I search for my image, suppose Docker for Ranjit, okay, slash, if I see, it gives me all the images, whatever under this Docker for Ranjit registered, right? I have registered with this name, and I have these images available. So all in my community. See, these are the images of mine, which I have publicly shared. Got it? I have this MySQL also. Now, what you can do here. Now, once you register, your task for you is to first register today with Docker Hub. Okay. Now let's move on. We have this server is running now. Let's try to install Docker and do some hands-on. Okay. What I'll do, just get the public IP address here. Get the public IP address and as usual, log into the server. The way you log into the server, either you use PuTTY or directly terminal to use, log into the server. Search. Okay. Got it? So I just connected to the server. Now let's do here, try to install Docker. Try to install Docker. It will be very simple, guys. Only one command you have to use. Sudo, okay, yum install Docker -yes. That's all. Sudo yum install Docker. Okay. To know more about the installations part, you can just use docker.com, right? Docker.io or docker.com. You'll find this is the official docker.com is the official page of Docker. Is the official page of Docker. You can find all the informations over here. You can find see build, share. That is what I have written, right? Build, share, run. It gives us, so what it says, Docker takes away repetitive mundane configuration tasks and is used throughout the development lifecycle for faster, easy, and portable application development. So what is build does is build get a head start on your coding by leveraging Docker images. We are going to build the Docker images, put together everything. You can just work on that, right? The packages and applications. Then share, you can share to anywhere. Leverage Docker trusted content, including Docker official images from the verified publishers, whatever I was just showing you in the things, right? We have Docker official images, verified. So what happens? We started building our images and then we shared in the internet and get it and run it anywhere. It's very, very simple, right? In case of virtual machines, you cannot do this, right? You have to need that machines to install and create the VMs. But here in this case, create the image, share it anywhere, get it that image, and any machines you can create it. That's very simple, right? Now, if I go here, need to install, right? They have modified and upgraded to Docker desktop. As I'm using the MacBook, by automatically finding the operating system and gives me to download the Apple Intel chip, this one, right? Download Docker desktop for Apple. It gives me. But if you're using Windows or Linux, you can click any one of these, right? Suppose I'll go with Linux, click on the Linux one, and it'll give us the required installation steps here. Required installation steps. And this is nothing for your Docker desktop. Okay, this is for Docker desktop. Docker desktop is actually one UI kind of tool where you have to just execute and you will not get that much fun there. Okay, so Docker desktop is kind of, you can just install Docker desktop in Linux machines, in MacBook, in Windows also. Okay, Docker desktops. And remember, guys, Docker has some prerequisites, some requirement. You can go with this requirement to install Docker Dexter successfully for Linux host. So you should have 64-bit kernel, okay, and KVM virtualization support on. And we need this key UEME must be version 5.2 or newer. At least 4 GB of RAM is required, right? All this information is required in case of this one, right? And he has some few steps here to install on different kind of machines, right? Okay, but I would suggest you very one simple commands to do practice and hands-on. You can just use standalone Docker command sudo yum install Docker. Yes, so I'm going to install on Amazon Linux. Then let's see. It's just installing all these softwares, right? This Docker is installing my machine. Just wait for a few seconds. It will be installed quickly. Yeah, it's done now. It's done. So what I can do here, let me just check whether the Docker is installed or not. If I just do Docker version, sorry, what it says, it gives Docker version, it gives us the client version, this much 20.0, and it gives the API version, okay? So, but it says cannot connect to the Docker daemon. Is the Docker daemon running? So let's see whether we just installed, but we have not started yet the Docker, right? What I can do here, let's check whether the Docker is running or not. System CTL status Docker. There is spelling mistake status. So it is inactive or dead. It's not running, right? So now let's first start it, right? You have to make sure you are under sudo system CTL start system CTL start and Docker. Okay, hit enter. Now if I check the status, see, it's now running. It's now running, right? So if I do here sudo, let's first make ourselves as root sudo su. Let's clear it. And if I do Docker version, see, it gives us complete version details of client, and it gives the server engine. This is the server engine and all the entire details it gives us. Okay, good. The things are installed now. And one more good things I'll just tell you to use for your help. What is that is whenever you need any kind of help, right? And if you forget any command to use that, simply use Docker help. Docker help. It will give you complete list of commands with the usage. So you can easily get it and work on it. See, it gives the complete usage of the Docker. The management command, the builder, right? The management command, the management commands, and we have this commands list of commands which are going to use with part of this management commands. So we have these management commands. Before we had only 5 or 6 commands out there, so 7 or 8 commands were there, but now they have increased multiple management commands they have created. Anyway, based on our requirement, we are going to use this. Most of the commands I'm going to show you. Okay, now this is a very simple things, right? Our installations is done now, and you can see here the management commands. I'm going to run first, work with this container management command. Container management. Suppose if you want to know how to use this container management command, how you can do? You can just use Docker container. The management command is container and use health. So it will give you the health of container command, container management command, right? See, so health and how to use is this one, manage containers, and these are the sub commands or commands you can use with the containers management command. Okay, now ls to list the container, kill to kill the container, logs to check the logs, rename, restart, stop, top, start, cp, attach, everything. I'll just show you most of these commands. Okay, now let's go ahead. Now everything we'll do the hands-on, right? Now what I'll do here, I'm going to show you today. So installations is done. Let's play around with the container. So I'll just use Docker container, okay, Docker container ls to check what are the if any containers available or not. See, okay, we don't have any containers available. Check whether we have any image available or not. So for that, we can use the Docker image management command ls. Here we don't have any image available. So what is the image, guys? The image is the recipe or template and can be used to create the container, right? So it is a bundled or packaged binary file. Okay, it is actually image a binary file which contains everything which a container need to run. So before creating the container, we should have the image available. Before creating the container, remember, before creating the container, we should have the image available with us. Okay, now, and remember, Docker container is a, so we know that two major objects are the image and container in case of Docker, right? So image, remember this point, image is a build time object and container is a runtime object. So what is this build time object and runtime object? Build time object during the build, after build, whatever is created, that will be the build time object. So when the object image is created and if you use running that image to create the container, that will be your runtime object, right? The container is the runtime object and image is a build time object. Now, we don't have anything available here. And suppose I want to create a container of Apache server. How will do that? Okay, how I'll do that? First thing, either you can directly use the run command, or what you can do, you can first pull out the image and then create container out of that. What I'll do here, I'll show you two examples with two different ways to do that. First, let me pull that image which I need to create a container. Suppose I want the Apache server, HTTPD server. Let's do that. For that, you have to use the command docker, okay, pull, docker pull, and give the image name. In my case, HTTPD. So here, I simply gave HTTPD, right? I simply gave HTTPD. If I don't specify any tag here, if I don't specify any tag here, what will happen? It will download the latest version of the HTTPD image. Let's see what happens using the default tag latest. See, remember that could be a question. If you don't specify any tag here, what will happen? It will download the latest version. But this is not what the requirement for your company or for your project. You could be using a different version of image. Then you have to specify that particular. Suppose here I need some different version. Okay, to find out which version you need, go to the Docker Hub, right? hub.docker.com, and there what you have to do, you have to search for that image. Suppose in my case is HTTPD. Sorry, not here. Search here. HTTPD. Hit enter. And here, click on this particular HTTPD official image, right? Click on this and go to the tags. Go to the tags. And here we have different tags available. We have different tags available. See, different tags. Suppose I need this particular versions. Suppose I need 2.4. Okay, I need this 2.4 tag. What I have to do here, simply use colon 2.4. Hit enter. Okay, here when I use tool Docker pull this particular 2.4 tag, you can see here 2.4 pulling from the registry or library, and this is the digest. So now I have pulled two images. I have pulled two images, right? So if I do Docker image ls, Docker image ls, right? Hit enter. See, I have now two images downloaded from the registry, and these two images are now locally available in my machine. These two images now available locally in my machine, right? Now, with these two images, suppose I want to, now what happened? I just pulled two images. In one of the image, I just want to create a container. How will do that? Use the Docker management command name is container, and use run command, that is to run an image to create the container. So I'll just use run. Then you can use various options here. One of the options I can use -d, that is in detached mode, right? And one other option, suppose I use give a name. Another option is there, suppose IT, interactive, means that will be attached to the terminal. That will be attached to the terminal. Let's give it IT and use a name, -name. Suppose I'll give a name as web app. Okay. Then you have to pass. We have to publish it to use this one. Suppose 80:80, 80:80, and then what we need, we give a name and then publish, and then you have to provide the image name, which image you have to use to create the container. Suppose I'll use HTTPD. So guys, if I don't give anything, what will happen? If I just use HTTPD, what will happen? If I don't give any tag here, what will happen?
So it will use the available or latest one.
Not available one. It will use the latest.
Latest one. Okay.
It will use the latest one. So be attentive, guys. Okay, listen whatever I'm telling. So you have to use the latest one. Suppose I want to create the container from 2.4 tag. So you have to specify which image. What will happen? Now it will create. See, it's just created the container. Okay, what will happen here? If you see here, if I use docker -it, it will interactively attach to the terminal. I cannot execute any command, further commands here, right? So for that, what I can do, let's Control C. Either you can just open another terminal and there you can search it, but you can use, if I see, even though I just use this one and it created container, let's see whether we have container created or not. We have Docker use container management command ls. So we don't have anything. Now if I do ls-a, check all commands, it will give us one container. So this command will give us only the running container, active container. And this command will give us all container, active, dead, exited, everything. Now you can see here, as I pressed Control C here to come out from this, because it was attached to the terminal, I could not execute any commands. So I pressed Control C. When I pressed Control C, it terminated the container. It exited the container 2 seconds ago. Now this container is dead. Okay, and we have this one container available. Now, if I don't want to attach to this terminal, what I can just do, I can simply use, instead of -it, you can use -d, -d in detached mode. Okay, in the background, it will run in the background, right? And we have already a name given. Let's give a different name as web app 1. Let's hit enter. See, it's just created a container and gave us the container ID, too big ID, right? This is the container ID. And And this container ID, if I just do Docker container ls, see, we have this container and it is up, it's still running. This container is now running, right? If I do container ls -a, it will give us both two containers. See, two containers, all containers, exited, also running container. If I just give ls, it will give us only one container. Now you understood this container. Now you'll be thinking, how will access this container? This container is having our application. How I'll access this application, right? As I have this command I used to port forward. This is called port forwarding or publishing. What is this? Just try to understand, guys. When I executed this particular 8080, so what is this 80? Is a port, default port of this Apache server. If you install Apache server on your laptop, on your machine, then you make sure that HTTP port 80 is whitelisted or firewall. Then only you can able to access the HTTP server, right? Same thing here. I'm using the container also. Whenever we create the container, also will have the port number 80 by default. And to access the container, we have to publish the port of container or forward the container port to the host port, to the machine port, to the laptop port. Then you can able to access that one from your laptop itself, right? From your internet itself, from your browser, right? That's why I have to forward it or you have to publish it -p 8080. The first one is your container port. This one is your container port and forwarding to host port. Container port is forwarded to host port. Okay. Now, if you want to give any different port name here, 82, then you have to use 82 in order to access the application, right? Let me do that. Okay. Now, how will access that one? So you need the particular IP address of this one. Get this IP address. And how will access the container? Go here, hit enter. See, it gives, it works. The container is running, right? So the container is running. Now, if I just want this container to stop, I'll do that. Use Docker container stop, right? Provide the container ID or the container name. Container name is web app 1, or if you don't remember, because this is quite difficult to remember the container ID, right? So better you can just give web app 1, or you can just copy this and paste it here, right? Hit enter. So I just stopped this container, right? Just wait for a few seconds. It will just get stopped. So the container is stopped. So if I go here and refresh this page, see, because our container is stopped now, we cannot turn. So here I deployed the applications, web applications with this container, right? Now, what will happen here? The container is stopped. Now, if I want to start this container, simply you just, instead of stop, use start. So it started the container. Now, if I go here and refresh, see, our application is running. This is one way. Okay, our containers are there. Now, let me just show you some ad hoc containers. Okay, ad hoc containers. Like if you want to use some containers, like create one BG box, okay, a small BG box, and you want to execute some commands. So what you can do, use Docker, okay, -g or Docker run, simply Docker run. Okay, give, if you don't give name, it's also fine. It will randomly give you a name. Docker run, just give BG box, okay, and give a command. Suppose command I'll give as date. Hit enter. So just try to understand this. I'll just tell you, right, what will happen here. See, guys, what it did, it just, first what it did, unable to find the image locally. Remember, guys, this is very what they can ask you, the life cycle of the Docker container, or they can ask you what is the flow of the Docker, how the Docker works. So you can say here, whenever you just execute the run command, Docker run command of particular image, the Docker, what will do, it will search that image locally. In our case, I'm searching this VGBox, right? If you just search the VGBox here, search the VGBox here, we'll get the VGBox image also. So what is this VGBox image? Actually, it is a very tiny, small Linux utility. Okay, VGBox coming with someone between 1 to n this size. VGBox combines tiny versions of many common Unix utilities. That's why when I executed this command, run docker run VGBox. So run means we are going to create a container out of this image. Then Docker will locally search Docker daemon, right? Will locally search for this VGBox, whether the VGBox is there or not in the laptop, in this server. If it is not there, it will download from the library, from the registry. Then first it pulled, right? It pulled from the registry, and then it created the container. After creating the container, it executed this command. You can see here, it gives us the date, right? It gives us the date. What is the time? 3:53, right? If I execute again, it will create another container and it gives us the date. See, 3:55, 3:53 I had executed. Now if I just executed another command, suppose instead of date, I'll just execute, suppose uname or uname. See, it gives, it is a VGBox, this container is a Linux container. It gives the command. Whatever the command you pass, it will execute. Now, how many images would have been created now for VGBox? Three containers. It would have created 3 containers now, here, here, and here. Now, we have not given any name, right? Let's do check here. Docker container ls-a, right? See, I have 1, 2, 3, 4, 5 containers. 2 for HTTPD and 3 for VGBox. And this VGBox has given a different name. See, Gen_tu, Objective German, Reverend Shannon. These names, if you don't specify any name to your command, to your container, if you don't specify a name to your container, it will give randomly a name to that container. Okay, so here, and immediately you can see all are exited. The nature of this container is, as it is a very tiny, small Unix utilities box, right? It just executed the command and then it will be exited. The container will not be live. But in case of this HTTPD, as it is running in the foreground, it is running the web applications, we need to access it, right? And the command, it is running in the foreground. See the commands which is getting executed, HTTPD foreground. This means it will keep the server to run all the time. Okay. Here I forcefully exited using Control C. That's why it is exited. Otherwise, it will be running. So our HTTPD server will be now, see, it will be still running, right? If you just put in your browser also, the container is on my server, right? On my machine, the container is running. As it is internet or publicly, globally accessible, if you type this IP address on your machine, you'll also get this page. You'll also get this page. Just type 43.204.24.38. You will also get this particular page available on your laptop. Okay, now what I do here. So what is the benefit of using this one? Again, I just used port 80 to access it. Suppose I want to create another container having a different port, So how I'll do that? You can simply have to, let's go to that. What I have to do, simply use, here, I'll use the command. Let's clear it out. Okay, let's clear it out. Okay. Use Docker, right? And container run -d, detached mode I'm going to run, give a name, okay, save two, and publish the port, suppose 82:80. Means the container port is default is 80, you cannot change it. It will be default 80, you cannot change it. I'm changing the host port. Through 82, I can access my container, right? Through 82, I can access my, just now give HTTPD. I'm going to use HTTPD. And if I don't specify any tag, it will get the latest tag, right? Hit enter. So it created another container. Within the fractions of second, our application is deployed. Within the milliseconds, right? If I just do Docker container ls, just do ls only. See, we have two containers are running. Web app 1, web app 2, right? And this web app 1 container is forwarded to port number 80 to host port, and this is forwarded to 82. Now, how I'll access this container? How I will access this container? I can just go to the browser, same IP address, okay, because it is running on the same host machine, right? Put the same IP address, but here we have to give port number 82. See, it gives 82, right? Port number colon 82. Now I have two containers running on my machine having different port 80 and 82. 80 and 82, two containers are running. Now let's do some changes. If I just want to do deployment of something, copy some index file, right? It is running on that, right? What I do here, let's first go inside a running container. How we can go inside a running container? Suppose this is the container, I just want to go inside this container. I'll do that. I can use Docker exit -it. Docker exit -it, then provide the container ID here, and then provide the bin bash. Hit enter. See, now I just came inside to the container. See, this is the container. I came inside to the container, and this is a working directory where I am currently. If I do ls-l, so these are the files available in this directly Apache 2 of this container. Okay, now let's come out from this container. Okay, this particular container is having our
I want to know how much RAM and how much storage it has taken. So can you use the command of -h and see the memory and the storage of how much it has taken, because we have not allocated any storage and memory while initiating that container, right?
Yeah, you don't have to necessarily don't have to necessarily do that one, because it will be automatically, as I said, right? Whatever memory is required for the application, it will get directly from the host operating system. But still there is an option to allocate some memory. I'll show you in the next upcoming classes. Okay, don't worry about that. There I'll show you how you can set off the CPU usage, how you can usage RAM memory usage and everything. Okay, everything we can do the setup. But if you want to do how many things they are using, there is a different commands are there. I'll just show you. So don't worry, guys. Everything I'll show you. Okay, Docker using top command, Docker top, and just give this particular. So it gives whatever the details we use and all. There are many other commands. I'll just go through this everything right now. If I just do anything here, Docker container, use help here. Docker top display the running process of a container. Okay, and Docker stat display the live stream of the resource usage utilized. You have statistics, Docker statistics, right? If I use Docker instead of top, if I use statistics here, stats, right? See, CPU, this is memory being used. This is the percentage and networks, blocks. Understood now, right? This is how you will do. So there are many commands we are going to learn slowly. Okay, don't worry. Let's come out from here. what is the command? Now, so if I just do Docker container ls, so these two containers are running, right? I want to do some changes to the index file, deploy a new index file. How I'll do that? Suppose bi index.html. I'm just going to create one index file quickly. HTML. Okay. So I just created this particular index file. Okay, I created particular index file in my local machine, my server, right, on my laptop. Now what I do, I just want to deploy to the container. I want this particular to copy to the container, this particular index file. I'll do that. What you can do, oh, I forgot this file, whatever it is. I need the path. That's why I went inside to get the path. Okay, path will be there. Wait. Okay, I need this particular path. Got it. Use your local Apache 2. Now what I do, I need to copy this. To copy this one, we can use Docker container CP, or you can use Docker CP directly also, right? No problem. Docker container CP, provide the file name, suppose index.html, I want to copy. Where you have to copy? To the container, right? Give the container ID or container name. Suppose this is the web app container I want to copy. Just give web up to either container ID or container name. Give the path where you want to copy. I just st docs. Here I want to copy this index.html file. Hit enter. Now the file is within the milliseconds it copied. Now if I go here and refresh this page, right? See, our application is deployed. Within the milliseconds, our application is deployed. It's very simple, right? I just copied that particular deployment. This is the one way to copy file, but this is not the real deployment happens here. Real deployment, we are going to create our own image and then we have do the deployment. This is not the deployment. This is simply I showed you how to copy that, right? It's simply copy the file. And remember, this copy can work only for a running container. The container which is running, you can copy the file. If it is dead or inactive, you cannot do that. You cannot do that. Okay. So, and if you see here, port number 80 is still having this old code, still having the old code. But to 82 container, I just copied to a new. Okay, guys, that's all for today's class. We are going to learn many more in our upcoming classes. In our next two classes, I think I'll just try to complete things. Next weekend, don't miss the classes. Next weekend, I'm just going to teach you more commands on the Docker. Also, I'll show you how we can build our own image stored in the registry, then how we can deploy the applications by using the images container, how we can create, and real-time deployment happens in the company organization. We'll do a project. Also, we'll go work on the Docker Compose to work on the multiple containers, right? Everything I'll do in our next weekend, next Saturday, Sunday. We are just going to cover complete topic, okay? That's all, guys, for today's class, and we can move to next Saturday.